And we should be live now here on NBC News Facebook page and several other Facebook pages. I'm meteorologist Rich Merritt here at Keene TV in Seattle, and this is Dr. Amy Snover, who's from the Climate Impacts Group over at the University of Washington. And we're going to be talking today about the specific effects that we're seeing in the Pacific Northwest and what we expect to see in the future. And also talk a little bit about some of what her group does over at the University of Washington in being able to take science and translate it into something that's actionable material for governments and the public and for businesses, as a matter of fact. So again, we're just learning the controls here on this guy. Let's see if we can get this guy to go up there. So we should be good. Let's see if everything's working for us. There you go. There's the Pacific Northwest. So Amy, your group basically is looking at the Northwest and trying to determine the changes that are occurring and how we can anticipate that in coming years and how we can mitigate that in coming years, potentially, correct?
That's absolutely right. We are doing the hard science to translate global climate model information into information about what changes we expect right here in the Northwest and why they matter to people who live here and everything we care about in this region.
And so the work that you've done so far is showing that we're already seeing impacts, correct?
We are seeing changes on the landscape that look exactly like climate change in terms of warming temperatures, changes in snowpack. We've lost about 25% of the snowpack since the middle of the last century. Changes in snowmelt and stream flow timing. A lot of the water in our rivers around here comes from snow, and so if you have a different amount of snow, it melts earlier when it's warmer. We've seen those changes. We've seen changes in fire frequency, and we've also seen sea level rise around the region. So we've observed those kinds of changes on the ground and seen some impacts in some specific years. And then we've also done a lot of work to figure out why any of this matters going forward.
Yeah, well, we should probably point out too that in the Pacific Northwest, we don't really store very much water. There aren't really huge reservoirs by and large, and we depend, at least in the summertime, which is a shock to many people. It doesn't really rain that much here in the summer. We go through a very dry period, and we really do rely upon snowmelt in the mountains to provide our water supply during the summers. And not having a snowpack potentially would leave us in a situation. We've seen it during drought years in the past where it's a little sketchy in terms of water. Nobody's dying of thirst, but a lot of brown, well, anymore there's a lot of brown yards and such that are around the area. But I guess we take a look at the what you're projecting out with 1.5 degrees of warming. We should talk, actually, I think maybe off the top a little bit. Some of you have been watching these, probably been hearing about this anyway. What is the significance of the 1.5 degrees of warming, global warming?
Yes, so I think a lot of people have heard about the international agreements and discussions about limiting climate change. And there was an agreement back in the 80s to limit climate change to a level that would prevent dangerous human interference with the climate system. So the big question is, what's dangerous human interference? How much warming is dangerous? And so that's been the focus of discussion for many years since. There was a big report that came out last October 2018, that was looking at the impacts of 1.5 and 2 degrees Celsius of warming, because those are the levels that the international community decided were dangerous. So the Paris Agreement said that the nations of the world would limit warming to 2 degrees Celsius, and make every effort to actually limit it to 1.5 degrees Celsius. So that was a level that the international agreements are targeting.
Yeah.
And so this report came out and said, well, how much warming have we seen? Right? If 1.5 degrees is a problem, how much has it warmed?
Right.
Well, it's warmed 1 degree, and this is again Celsius, so almost 2 degrees Fahrenheit. So it's warmed that much since the industrial revolution.
And this is the global average of temperature
This is the
that we're looking
global
at.
average. And so then the big question is, okay, so what happens at 1.5 degrees of warming? And that was the big report that came out in the fall. Well, we did a report interpreting that for the Northwest. And this is the figure you were just showing that says, what might we expect in the Northwest when there's a change in global average temperature of 1.5 degrees of warming. And that's what we show here. So, and this is a nice summary for everyone of the major initial ways that climate change will manifest in the region. So when it's warmer, we have more very hot days.
And so in terms of just high temperatures during the summer, or just generally through the year, or?
Yeah, well, so hotter on average, right?
Yeah.
Warmer temperatures all the time, and our summers are the hottest time, and so our very hot times and our heat waves tend to be in the summer.
And we're tending to see that already.
We are seeing trends in nighttime temperatures, right? Nighttime heat waves, and that's when we would expect global warming to actually manifest first.
That's to show up in the minimum temperatures.
It's shown up in the minimum, because you're a meteorologist, you know that even better than I do. Yeah, and so that's been observed.
Yeah.
And then also we would expect reduced snowpack of around 40% with that amount of warming. Higher winter stream flow, because again, you mentioned that in the Northwest here we get most of our precipitation in the winter, and if it's warmer, it will be raining instead of snowing.
And going to the streams
And
at
then
that
going
point,
down the
rather
streams,
than-
and so we have higher winter
Rather than
stream
saving
flow.
our money for the lean times, we're spending it all in the middle of winter when we do get quite a. You may have heard, but there's occasional rain here in the Northwest.
Yeah, it is hard for sometimes for people to handle the
Yeah.
rain. But and then what are the lean times? The lean times are our summer, right?
Right.
Late summer is when we have low stream flow, typically in rivers that have snowmelt.
Yeah.
That's when salmon are returning and really need water in the rivers, and they need cool water in the rivers. But with less snow and warmer air temperatures, we would expect both less water in the rivers and warmer temperatures for the fish.
Right, and we're starting to see some of that already, as we've seen some really limited returns on some of the salmon already.
Yep, salmon have challenges in many years, right,
Yeah.
with limited returns from a bunch of different reasons.
Right.
But we can look back. 2015 is a year that a lot of people noticed around here, where we in our group kind of called it a dress rehearsal for climate change. And that was a year that had among the highest temperatures. Well, it had very high regional temperatures. It was almost 5 degrees Fahrenheit warmer than average. And we had record low snowpacks as a result in Washington and Oregon. And then we saw a lot of different, let's see, it is number.
So working this out,
We're
there we
doing
go.
lots of things at once, so
Yeah.
14 and 15.
There we go.
So 2015, we call it a preview of the future. It was the warmest year on record for the Northwest. It was quite a dry January to June, and as I said, the lowest snowpack on record for Washington is 30% of normal. And then if we go to our next picture, it's a summary of a bunch of the impacts that were actually observed that year. This is ways. So the question people always ask me is, why does it matter, right? It's
Exactly.
Oh, whatever. It's almost 3 degrees Celsius warmer. That's not very much. Does it really matter? Well, 2015 gave us a preview of why that might matter. So these temperatures and changes in snowpack and stream flow really matter for fish, as we said, right? And so we saw in that year almost 250,000 sockeye die in the Columbia River. Combination of the warm temperatures exacerbating diseases that were already there.
Mm-hmm.
We saw really low snowpack, which caused short ski seasons. It was our largest wildfire year on record. We spent almost $250 million in fire suppression that year.
Just here in the Pacific Northwest.
Just here in the Pacific Northwest. That might even be a Washington state number, I'm not sure. And then also agricultural losses.
Yeah.
So we're giving a litany of impacts. Maybe we should dive into ones that are particularly interesting, or talk about
Sure.
the way it relates to the weather you're seeing.
Well, which we can talk about, how it's going to be affecting the amount of snowpack that we have here in the Northwest as we go into our summers, which would be, again, we're navigating quite a few graphics here at this point.
That would be number 4.
Got it. It's behind the scenes here.
So I think we all know that we need cold temperatures for snow, right?
That helps.
It helps. I don't know if you've ever gone skiing and had a warmer day than you really wanted and had it be raining, but that is what climate change will bring more of. So one way we look at that is we look at global models, and then we extract information about the region and say, how much snow do we expect in our Washington mountains as the climate warms? So this map, I think that we're looking at now, shows where our snow is typically at the beginning of April. So you mentioned before we don't really have big reservoirs.
No.
The mountains are our reservoirs. So this is our water storage for the summer, and it shows you where the mountains are. So if we go on to the next one, what you would expect as it warms, we will see less mountain snowpack. So by the 2020s, we might have a loss of about 30% snowpack in an average year in Washington. We can skip forward, and as warming continues, we would see by the 2040s about a 45% loss of snowpack. And then by the 2080s, it's quite a bit more. I think it's 65% loss of snowpack.
So this is the snow that we're going into our summer months with that's going to supply our water for the winter.
It will supply our water for the summer
I
and
mean,
the fall.
for the summer and the fall.
Summer and
wrong
the
season,
fall.
yeah.
So this is water for people and farms and fish, cities, industry. It's also water for forests, right?
That's
This
true.
is our mountains are full of forests that need water. And so this is something we identified about 20 years ago as the dominant impact pathway that climate change would use to affect the Northwest.
Through this change in the amount of snowpack
Through this
that's going to be
change
on
in the
ground.
amount of snowpack and summer water supply.
And so we've heard over time they've been talking about the fact that as we head into more of the effects of climate change, our summers here will be warmer and drier, and our winters will be wetter, but they'll be warmer. So we'll have more stream flow in the middle of winter when we don't really need it, and not have it in the summertime when we do need it.
That's right. And we should just be careful when we talk about winters being wetter. We mean that it's raining instead of snowing.
Exactly.
And we mean that there's more water in the river. But if
Right.
you added up the precipitation, it might not look very different,
Oh,
right?
really? Well, that's
Yeah, because
interesting.
if it's warmer, it's falling as rain.
True.
The other thing, though, is that the type of rain or the amount of, the type of events that we see to deliver the precipitation will change, right?
Right.
So with climate change, we expect heavier rainfall. So when it rains, raining harder.
So probably more flooding events with that potentially. And so as they were saying, I think the governor of California was saying yesterday, the hots are getting hotter, the dry is getting drier, and the wets are getting wetter. I think it's kind of a good description of what we've been seeing already up here in the Pacific Northwest.
That's a nice way of putting it.
Yeah.
Another way people talk about it for us up here is climate change means more water when we don't need it
Yeah, which
and less water when we do.
exactly. So that's going to be the primary impact that we're looking at here.
And a big reason that this matters, of course, is that we have developed our society based on our expectations
Right.
and a history about when water would arrive and in what form. So the reason we don't have reservoirs is we didn't need them. We
Right.
had mountains and snowpack. The reason we grow the crops we do is because we have a climate
Yeah.
that is suited to those crops. And so the challenge is when the climate changes, it's the foundation of everything shifting.
Well, this also affects. Here in the state of Washington, Pacific Northwest generally, so also up in British Columbia, where the Columbia River, which is one of the primary suppliers of water into eastern Washington, where much of the agriculture is, the amount of stream flow there in the Columbia, the river flow in the Columbia, is going to be down a significant amount in the summertime as well, potentially. Is that correct?
Well, yes. The Columbia is complicated, right? Because it's managed, right?
Right.
So the amount of stream flow you see at any one time is a combination of what actually was happening because of snowmelt or rain and what actually was happening because of dams and reservoirs releases. But the natural amount of stream flow in the Columbia will decrease in the summer months.
And this problem really kind of trickles down literally from so when you have the lower stream flows, you have warmer waters coming through those streams in the summertime. It affects, as you were saying, the salmon return. And we saw just an example, one of the local areas where they count the salmon coming up, called the Ballard Locks here. The count of I think it was the summer Chinook salmon, which used to be in the 100,000s. It was only 17,000 fish that came back this year. So part of it's a combination of things because there's warmer temperatures in the Pacific, which is affecting things as well. But also just these lower stream flows. And there's constant competition too. I think that's an important part of all this. The water is used for so many things. We generate a lot of hydroelectric power up here with the dams. And they're forced anymore in order to maintain the salmon to release that when they don't necessarily need to generate power. And that's a conflict that they have too, isn't it? I mean, that is one of the problems, is how do you optimize the release of water that we do store basically up to Columbia? How do you optimize that for maintaining the fish and also maintaining the hydroelectric supply?
That's right, and those aren't the only two reasons that we run the dams on the Columbia, right? So we want to protect and actually restore salmon runs. We are making hydropower. We have carbon-free energy that we rely on here. We're really proud of and happy to have. One of the biggest reasons the dams were built in the first place was for flood control.
True, yeah.
Right? And so you have to operate them thinking about when there's going to be heavy flows to protect downstream communities like the city of Portland from flooding.
And that's a problem when you're going to be getting heavier rain events during the course of the winter as well.
Yeah, and it's especially a concern in smaller watersheds. And then, of course, agriculture, right? A big use of Columbia Basin water is for the agriculture we're so proud of in Washington. So it's the challenge of matching all of these different uses in a time when availability is changing, when the supply will be available at different times, and during our times of shortage, our late summers and our droughts, those will be worse.
Yeah, and just to mention also, I mean, the orcas, which we have several pods of the whales that exist here in Puget Sound, there seems to be a struggle going on. There's questions of what is really affecting them. And what is the best research that you know of right now in terms of that?
Well, I could talk a little bit about climate change in orca, and one of the major items of concern. So orca are our killer whales, right? They're beautiful animals. Some of them live here in Puget Sound. Some of them are listed as endangered. One of their major, they eat Chinook salmon. We've just been talking about the challenges that salmon have, and so one of the major ways that climate change will affect orca is through salmon. Right, so we've already talked about warm temperatures and low summer stream flows and that challenge for salmon, but we didn't mention that those floods that we're talking about can also be problematic for salmon. When there's really, really high river flows in some of our rivers, the salmon returns decrease, and that's because the salmon eggs are incubating, right, and they're getting washed away or suffocated from the dirt in the stream, the sediment in the stream. So there's a lot of different ways that climate change will affect. We can use the salmon as an example, but we could talk about people as well.
True.
Name something, and we could talk about the climate links to it,
and
how we. I think. So we've been listing a lot of the different impacts and a lot of the different changes, and I think it's really important for us really to recognize that these changes, at some level, they're not something off in some imaginary future that may or may not happen. We are on a path towards these changes.
And we're starting to see them happen already here.
I mean, we have a choice as to whether we get off that path or where we continue walking in that direction. And when the work we do in our group, the Climate Impacts Group at University of Washington, is really oriented towards doing our best to understand the risks that climate poses for the region so that we can use that information in our planning and decision making. So when you're working to restore salmon habitat, make sure you're doing it with an eye towards how the flows will change in the future so that they'll still thrive when the flows are lower in the summer and higher in the winter. When you're building a bridge over a river, build it for the river of the future, not the river of the past.
And this is one of the primary things that your group works on, is, as we were saying at the top, was taking the cutting edge research and observations and producing information that will help governments and businesses and people plan to live in what our future climate is going to be. Because no matter what we do right now, it's going to continue to change for quite a while, even if we could stop the emission of greenhouse gases today.
That's right. We have set change in motion that we're not going to be able to stop. And so our question is, are we going to prepare for that change? The sea level rise, increased floods and high flows in the winter, all of these changes. And so, that's what we do. We do the science to say how much, how fast, where. And then we work with folks who are making decisions to say, okay, as you build that bridge, as you design that water treatment plant, here's science you can use to make sure it works in the future. And we also have to remember that every day we have a choice about how bad that future gets, right?
True.
So we've set changes in motion, but the question is how much change is going to happen? And that question hasn't been answered yet.
That one we can still have an effect on.
That's right.
So we'll speak a little bit about here in the Northwest. I'm interested in this because I really haven't looked at this very much, but in terms of sea level rise here, how is it going to affect us here in the Northwest? Obviously, we have a lot of water around us, not only coming out of the sky, but also just with Puget Sound, the lakes. Well, they're not tidally driven, but the ocean Pacific is just out there, the strait. A lot of our waterways are going to be subject to sea level rise.
Right. So sea level is rising globally, right? And it's doing that because the ice sheets are melting, and because actually when water's warmer, it takes up more space.
Right.
So as the oceans warm, they get bigger.
In fact,
Right.
that's been the primary source of sea level rise so far, is the warming of the water, rather than the melting of land-based glaciers.
I think
which
you're
is
right,
Just
right.
getting underway. Something to look forward to.
So here we have seen in like the Puget Sound around Seattle, we've seen about 8.5 inches of sea level rise over the past century. And we project that for the middle of this next century, about another 8 inches by 2050, and maybe 2 feet by
Wow.
2100. And that's the middle of the road estimate, right? If you were,
It's not the worst case.
it's not the worst case, and which could be quite a bit more. So the interesting thing about sea level rise is it's not going to be the same everywhere, right? And
Oh, you mean it globally? It isn't the same everywhere.
That's right, and it won't even be the same everywhere in the state of Washington,
Oh, that's interesting.
because our land is actually moving up in some places and down in other places.
When it isn't shaking, right?
When it isn't shaking, yeah, there's an underneath kind of. So, if you look back in history, there are places around the state where sea level hasn't risen yet. And that's because the land is uplifting
And staying ahead of it
and
so
staying
far.
ahead of it. But as we look forward into this century, sea level is going to win. Sea level rise is going to win on that one.
And what do you think the effects of that are going to be? It's going to breach bulkheads, seawalls, et cetera? Do you know, so they just completely rebuilt the seawall here along the waterfront in Seattle. Did you guys have any input into that? I mean, as to how they rebuilt it or gave them information?
We had developed sea level rise projections for Puget Sound that I understand were used in the decision and the design of the seawall. So yeah, this is the kind of application of our science that we have, right? So we can produce the science saying here's a range of possible futures for sea level rise and advise on your choice of which number to use in your planning, right?
Well, another thing we were talking about just a little while before we went on the air is in the Pacific Northwest, we've recently, in recent summers, not this summer, we got to break this summer, but this is a satellite picture from a year ago, August, and all the wildfires over the Pacific Northwest, up in British Columbia and also in California. That smoke trailed out over in Puget Sound Basin. Most of the state, in fact, as you can see in the satellite picture, was subjected to a lot of wildfire smoke and with high pollution indexes. And this has really got people's attention. Even though we've only had really 2 summers of this where it was really extreme, this is one of the things people really talk about now. It's climate change.
That's right. I think wildfires are really on a lot of people's minds because of what we've experienced in Puget Sound, the smoke those couple years. The state of Washington had, our largest wildfire season on record in 2014.
Yeah.
And then in 2015, we had our largest wildfire season on record. So, and then of course, we've seen things that have been happening around the country, right?
True.
So, in forests across the state, climate change increases fire risk.
True.
And so there's lots of reasons that we've had fires in the past, and they're a combination of climate and management. We've decided to put out a lot of fires. So there's
So the undergrowth is built
right,
up. So
and fire
more-
ecologists
yeah.
call it a fire deficit that
Yeah.
we have to overcome. In addition, climate change increases the risk of fire. So we expect, quite a few more fires and more larger fires under climate change. And then you were asking about smoke, of course,
Right.
where there's,
Yeah, it does work that way.
yeah. And so, we don't know exactly where the fires are going to be in the state, at which year in the future, and which way the wind's
Then
blowing
that's
when
the
that's going to
important
happen.
thing.
However, if I were a betting person, I would put my odds on having more smoke.
More smoke headed
and
over.
having more smoke over here
Well,
as
it's
the years go
interesting
forward.
how intertwined the whole system is, because I mean, one of the problems we have in the Northwest, because of warmer winters, over the interior where there are a lot of pine trees, the pine beetle's been able to come north, and it has killed literally thousands of square miles of pine forest up in British Columbia, and that was a large portion of the smoke we saw there from
Right.
August was coming down from these huge fires in British Columbia. These standing trees, which are basically dead. That you know, and that just speaks to the complexity of the whole system. It's pretty amazing.
Yep, you know, when forest ecologists talk about climate and forests, they talk about disturbance, and disturbance is, you know, anything that disturbs the forest. So a fire is a pretty big disturbance, but insects outbreak are also a disturbance. And then drought stresses forests. So it's a vicious cycle, which is that the more stressed a forest is, or the more stressed the trees are, the more susceptible they are to insect outbreaks.
That's true.
That can increase fire risks. And so another major impact pathway for the Northwest of climate change is through these impacts on forests, which over time will lead to a dramatic transformation of the forest landscape.
Yeah, it's pretty remarkable. Well, we're going to take some questions. We've gotten quite a few questions here, but we thought we'd get through and just lay down some basic stuff, but we'll answer some questions here. I'm going to slide in a little bit closer so I can take a look at these. Okay. I have to get even closer. There we go. We'll find something that actually is germane to what we're talking about here. Okay, this is from, they want to say the climate has always changed and it's continued to change. You do not have control of this. The science is settled and the debate is over. That's true, it has always changed, but I mean, and there's been big disturbances of climate, and I think that's one, the fact that's happened in the past, there's a couple things that have changed since it's happened before, and one of those is 7.5 billion people living on the planet with political boundaries that can't move with, because they used to, I should be letting you talk about this, but it's a passion for me as well. I mean, in the old days when the climate changed, people and animals migrated north or south, depending on which way it was going. Not an option now. And so we start to change the climate, you have even more problems.
That's right. And another dimension of that is that the climate change that we're anticipating, that we, you know, has been set in motion by burning fossil fuels, is going to happen more rapidly than the changes in the past.
Exactly.
So even if there weren't things in the way of people and animals migrating, people might be able to do it fast enough, but animals and trees and plants certainly are unlikely to be able to adapt fast enough. So that's one aspect of it. Another aspect is we really have been focusing on climate change right now. And we also live in a really variable climate. I mean, you wouldn't have a job otherwise, would you?
That's true.
Right? Right?
It's like
we don't know
Hawaii,
if
you
it's
don't
going
have a whole lot to talk about
You don't know if
weather-wise
it's going to
day-to-day
be wet or
anyway.
dry or what,
Yeah.
right? And so that part's going to continue. And so, you know, as we think about our path to a warmer future or our path towards a future with less snow, it's actually going to be a bumpy road, right?
Yeah.
We're going to have some cooler years. We're going to have some high snowpack years. But the trend is in a direction that
But
we've been
whereas in
talking
the
about.
past they've been frequent, the high snowpack years, they're
Right.
going to become increasingly infrequent.
That is correct.
And actually, I've been forecasting for up here for over 40 years, and I have seen this change in our winters that we just don't, on any given winter, they just don't seem to have as much snow that comes down. Again, we've had some big ones recently.
We have some big ones.
But then we have the ones that, like 2015, where there just wasn't much snowpack through the winter.
That's
So
right.
that change is starting
2015,
to-
again,
yeah.
was a window into the future, right? Because it was super warm, and it was warm when it precipitated, and so we had a snow drought.
Well, and I have a lot of people that talk, well, you know, there's these feedback mechanisms they've heard about, you know, and if we push it this way, then this compensates, and the Earth has been able to maintain a stable climate, and it'll bounce itself back. But isn't part of the problem with that the time scale for that adjustment is kind of beyond humans' civilization's time scale? I mean, like some of the things would have to kick in to have it naturally correct have to do with time scales of tens of millions of years for that to happen.
Yeah, you would have to talk about geologic timescales
Yeah.
for natural correction. And in fact, we haven't stopped causing change, right? I mean, it's not as if we've put a bunch of greenhouse gases in the atmosphere and then we've stopped and we're asking for things to like readjust.
Yeah.
We're still doing it. So I don't know of any mechanisms, in fact there aren't, that are just going to make that go away.
Yeah, and that it is one of the underlying problems here. Let's see. It says the Arctic Ocean is warming up Icebergs are growing scarcer, and in some places, the seals are finding water too hot, according to a report from the Commerce Department. Let me get this board. Is there a question? It's just a statement, I guess. Okay, let's see if I can find some questions in here. Not a whole lot of questions in. Here we go. In addition to impacts, okay, I don't think the moon is wobbling off its axis. So it says now we need to pay attention. Well, anything, while I'm looking for a question in here somewhere, do you have any other comments? I mean, anything you'd like to say about specifically the Pacific Northwest and changes that are going on here in the Pacific Northwest?
Yeah, let's see. Let's just maybe try to. We've thrown a lot of details at people, right? So let's just think about the big picture. The big picture is we're causing the climate to change, and in a few decades, the average temperature in the Northwest will be warmer than the hottest years of the past. Mm-hmm. It's not much of a leap of the imagination to understand that that is a different world, and that all these things we've been talking about, hot days and heat waves and floods and droughts and stress on infrastructure and stress on public health, all of those things will increase. And so, it's incumbent upon us to both limit that change and to do what we can to prepare for that change. So we were talking about what the Climate Impacts Group does, and that's part of that work is preparing for change, making sure people are aware of the changes. And I should also just mention that we're lucky to be part of our home at the University of Washington that is actually dedicated to doing science that supports society and really applies science in ways that can be useful for decision making. So our home is Earth Lab, which is an institute at the University of Washington, and its motivation and mission is to ensure that people and nature thrive. And that's in the face of any environmental change. So we're proud to be working on climate change, and there's a bunch of other programs at Earth Lab for when you have Ocean Acidification Day or Nature and Health Day that we can come in and talk to you about that.
Yeah, and you speak to yet another problem that's taking place is ocean acidification. By the fact that the oceans are absorbing these massive amounts of carbon dioxide. I mean, in fact, was it 80% of the increase in carbon dioxide has been absorbed by the oceans so far, rather than being in the atmosphere? It's somewhere in that vicinity, and that causes acidification of it. And I believe your group worked with some people here who I believe was the oyster farms that were having problems with the more acid water. Right. So
one of our sister organization in Earth Lab is the Washington Ocean Acidification Center, which is actually works broader than UW and with other entities. They are doing the science to understand how much the oceans and our coastal waters are acidifying, right? We're sort of the early warning for what the globe might experience. And why does it matter? It matters because things with calcifying shells, like little baby oysters, can't form their shells in those acidified waters. So a lot of the work of the Ocean Acidification Center has been with the oyster industry, helping them predict when these episodes will happen and helping them address them.
Right. So the mitigation portion of this equation, which is really important in the future.
Right.
So we're going to have to live with climate change. We'll have to find a way to live with climate change.
We, unfortunately, are going to have to live with climate change. And my fervent hope is that we decide to only live with a small amount of climate change.
Well, I think we may wrap it up. I think we're just about out of time here. Let's see if there's any quick questions that have come through. It's mostly just statements that we're getting from people. Not much in the way of questions today, but I think people take, it's been an interesting evolution over time. I mean, having been in the weather business for a long time and having watched this evolution of people's noticing the fact that things are getting different. Because it takes a long time for things to change, or it has in the past. And I do remember way back in the 80s in some of the research, they talked about the fact that the ability to, the signal of climate change, the ability to detect that the climate is actually changing, wouldn't be of high enough amplitude until we got into the 21st century, which is pretty much how it's been. And then that signal is amplifying now, so it's becoming more and more noticeable. Witness the smoke problems we've had, wildfire smoke problems, which is, again, we've had it for 2 years, and this spring that was all anybody could talk about was, is there going to be smoking in the summer? We were talking about this, a normal Northwest summer this year, where temperatures were in the 70s and 80s, and we didn't have stretches of 80s and 90s, which we've had a lot in recent years. And people were thinking, oh, it's cold. But in fact, our months, both June, July, and August, all were above normal in terms of the average high temperature. So maybe that's how we're mitigating. We're adjusting to the temperature change. You know, the other interesting thing is that it used to be that not very many people in Puget Sound had air conditioning. I think as recently as about 15, 20 years ago, the number was down around 10 or 15% of homes had air conditioning. And I think that's up around 25 to 30% now, as people are mitigating, they're adjusting to the increased temperatures around the area. So.
Yeah, if we're not careful, those choices are a vicious cycle.
Well, that's true, yeah. So you can only cool so much after all, and produce enough electricity to do it. But any hopeful things you can add? I mean, as we wrap up here, I mean, how do you feel? I mean, you're right at the front lines of the battle to try and live with the changes that are heading our way. Do you find the fact that it's more accepted now, the fact is the climate is changing and that we need to do something about it? Does that give you hope?
I'm really heartened by the energy
Yeah.
that people are bringing to the issue. And I am really hopeful that that they continue that energy and that we really decide to make a difference.
Let's hope so. Well, thank you for spending some time with us. Hopefully we didn't do too many numbers for you. It's certainly an interesting field, and for the youth of today, well, the ones that are going to be out, I think, marching tomorrow, in fact, is the day the climate marches are taking place. Hopefully we'll hand them a world that they can live in and finish making the changes that need to be made. So,
Yep,
thank you so much. Go ahead.
Oh, we're all in it together.
We definitely
We all got to do our part.
There's no good way to get out, that's for sure. So,
Yeah. All
thank
right.
you all for watching, and well, have a great afternoon. The weekend's almost here.
Thank you.